This section examines suspension system bushes. Bushes act as bearings at suspension fulcrum points to allow for movement of the component while maintaining its alignment. They can be metallic or made of rubber, nylon or urethane. In commercial vehicles, metallic bushes are commonly used as shackle bushes for leaf springs. Any force applied to the bush acts through it to the body of the vehicle, which results in a harsher ride. The mounting pin on a metallic bush is usually drilled to allow for lubricating the bushes. Rubber bushes isolate noise and harshness and dampen unwanted vibrations. Rubber bonded bushes can be used to mount the steering rack to the vehicle frame. The rubber absorbs small impacts from the suspension action without transmitting them to the vehicle. Rubber requires no lubrication. Spring shackle bushes can be molded to form two halves to fit into each side of the spring eye on the swinging shackle. With the spring loaded and the shackle plates tightened, the rubber is compressed in the eye and at the face of the plates. As the spring deflects, the rubber shears without tearing. Metallastic or rubber bonded bushes are normally used for the front eye of the spring at the fixed shackle point, and also in control arm applications. The bush has a steel outer casing and inner sleeve. The rubber medium is bonded to both to provide flexibility between them. The outer casing is normally pressed into place in the component. Relative movement between the casing and the inner sleeve causes the rubber to shear without tearing. In control arm applications, particularly at the rear of a vehicle, the rubber arm may be molded with a voided section. This is known as a compliance bush because it allows the unit or component to comply with a controlled amount of movement in the direction of the void. This movement relative to the vehicle frame allows compliance or deflection steer of the road wheels when cornering. Since this influences the steering behavior of the vehicle, it is very important the voided section is in its correct relative position.